Hi, and welcome to this video on Dalton's atomic theory. In this video, I'll be reviewing some key basic fundamental laws of nature that led to the formulation of the theory. I'll also discuss each of the postulates of this theory, and then we'll establish whether each postulate was ultimately correct or incorrect. Now, you may recall from a previous video that I did that at the end of the 1700s and at the beginning of the early 1800s, there was a series of natural laws dealing with the behavior of matter that were formulated, and these laws ultimately led to atomic theory. So since they're so important to this story, I figured I'd take a moment just to review them. So the first law is the law of conservation of mass, and it states that in a chemical reaction, matter is neither created nor destroyed. The second law is the law of definite proportions, and this law states that samples of a given compound, regardless of source or method of preparation, have the same proportions of their constituent elements. And the third law is the law of multiple proportions, and this law states that when two elements, A and B, form two different compounds, the masses of element B that combines with 1 gram of element A can be expressed as a ratio of small whole numbers. Now, this final law was formulated by John Dalton in 1804, and when he published this law, he already had the idea that in order to explain the behavior of all three of these laws by one explanation that was consistent, you had to take a view that all matter was composed of indivisible particles. He referred to them as atoms. And he felt that if you explained the composition of matter being made up of particles, each one of these laws could easily be understood under that framework. So then a few years later, after the law of multiple proportions, he actually came out with his atomic theory. And his atomic theory has 4 postulates. The first one is each element is composed of tiny indestructible particles called atoms. All atoms of a given element have the same mass and other properties that distinguish them from the atoms of other elements. The third is that atoms combine in simple whole number ratios to form compounds. And the fourth postulate is that atoms of one element cannot change into atoms of another element. In a chemical reaction, atoms only change the way they're bound together with other atoms. So now that we've expressed each one of the postulates, let's go one by one and establish whether they're ultimately correct or incorrect. Okay, so the first postulate that we're going to discuss is each element is composed of tiny indestructible particles called atoms. Well, now in the 21st century, we actually have the ability and the technology to be able to image matter at the atomic level. And we do see that indeed matter is composed of these small particles called atoms. However, Dalton was incorrect on the fact that he referred to these particles as being indestructible or indivisible. Dalton pictured atoms as being hard spheres, similar to being like a billiard ball, where it couldn't be broken down into simpler components. But it turns out that he was totally incorrect about that. Unfortunately, he didn't know about the existence of subatomic particles. He didn't realize that atoms are composed of a nucleus, and that the nucleus has protons and neutrons in it. And he also didn't realize that there were electrons that were surrounding the nucleus in the atom. So he was partially correct on this first postulate, but then he was also incorrect on some parts. The second postulate that we want to discuss is all atoms of a given element have the same mass and other properties that distinguish them from the atoms of other elements. And to a certain extent, he was correct. Although atoms of one element have a different mass and different properties from atoms of another element, he was incorrect on the fact that atoms of the same element have the same mass. Unfortunately, he wasn't aware of the concept of isotopes. Now, isotopes are elements that have the same number of protons, but that have different number of neutrons and therefore different atomic masses. And an example of a series of isotopes would be in carbon. So carbon has 3 isotopes. Carbon-12, which has 6 protons and 6 neutrons, and having an atomic mass of 12 AMUs. We also have carbon-13, which has 6 protons and 7 neutrons. And since this has a different number of neutrons than the carbon-12, it has a different atomic mass of 13.003 AMUs. And then there's a third isotope of carbon, which is called carbon-14, which has 6 protons and 8 neutrons. And its atomic mass is 14.003 AMUs. So Dalton was unaware of the fact that different elements can be made up of a series of isotopes that have different masses. Now, what about the third postulate? atoms combine in simple whole number ratios to form compounds. Well, it turns out that he was totally correct on this. And in fact, what we're going to be seeing all throughout this semester is that we're going to be dealing with compounds that are formed by whole number combinations of atoms, such as carbon dioxide having 2 atoms of oxygen and 1 atom of carbon, or a molecule of water that has 2 hydrogen atoms for every 1 oxygen atom. And we'll also be discussing compounds that are made up of whole numbers of ions, such as sodium chloride, which is table salt. Now, the fourth postulate of Dalton's atomic theory is that atoms of one element cannot change into atoms of another element. In a chemical reaction, atoms only change the way that they are bound together with other atoms. Well, this postulate is somewhat correct and somewhat incorrect. The first statement about atoms of one element not being able to change into atoms of another element is actually incorrect. And this is due to the fact that Dalton had no idea of the existence of the nucleus, and he also had no idea of the possibility of having nuclear reactions. Now, in a nuclear reaction, what happens is that a nucleus of one element is being transformed into the nucleus of one or more other elements. And an example of this is the uranium-235 nucleus being bombarded with a neutron to form 2 different nuclei, a nucleus of krypton-93 and also a nucleus of barium-140, which are 2 different elements being formed from one element. So this idea of an element changing into another element is actually possible. However, the second part of the postulate, that a chemical reaction involves only the change of atoms and how they're bound, is actually totally correct. And an example of this is a simple reaction that takes place when we have methane, CH4, reacting with oxygens to form carbon dioxide and water molecules. Now, if you take a look at this reaction, you'll notice that the number of atoms before the reaction takes place and the number of atoms after the reaction takes place are the same. We have 1 carbon atom on both sides of the equation. We have 4 oxygen atoms and 4 hydrogen atoms present. The only thing that's different between the products and the reactants is how the atoms are bound together. And we're going to see in this course several times that really all a chemical reaction is a breaking of bonds between some atoms and the making of new bonds between other atoms. So this postulate was pretty much correct. So all in all, when you stop to take a look at all of these different postulates that Dalton put forth, he was pretty spot on for most of the postulates. Now, he was wrong on certain things, but you have to give this guy some credit. You really have to give him some respect when you think about the fact that these postulates, or this atomic theory, is still a theory that, for the most part, that we're following to this day. And this theory was devised all the way back in 1808. And if you think about the technological advancement in the 1800s, all they had the ability to do, for the most part, was to measure the masses of compounds. And just by being able to take a look at mass data, the fact that Dalton was able to come up with a theory that we still follow to a large part today, that's pretty good. So all in all, he did pretty well, and good job, Mr. Dalton. Okay, so now that you've watched this video, you should be able to state the postulates of Dalton's atomic theory, and you should also be able to state whether each postulate is correct or incorrect and why that's the case. Now, in chemistry, we're going to be using the concept of the atom an innumerable amount of times. The atom is the cornerstone of chemistry. So being able to picture matter appropriately on the atomic level is going to be really important for us to understand future concepts dealing with matter. So the better that we can understand matter on the atomic level, the better this course is going to be for us. So hopefully you have a better sense now of how to think about matter. All right, so I look forward to seeing you in future videos, and take care for now.